Welcome to my Solar Ute project. We're converting our ute from a perfectly functioning, but smelly, diesel engine, to a clean, electric motor with a 22 kilowatt battery. So, why Solar Ute? Well, it's because we're charging off a large array of solar panels. We bought the diesel ute to replace an even older petrol ute. We use the ute on our bush block, and we already stored diesel for the tractors etc. In recent times, we were already thinking about doing an EV conversion. But things change. It's called the 2019 Summer of Fires. But for us it really started in spring. It did end in December though. It's hard to remember the thought process, but out of the ashes, we decided to convert the diesel ute. Then, as we all know, the pandemic hit. With border closures, and an elderly parent to look after, we were stuck in Brisbane. What better time to do an EV conversion? The Nissan Leaf motor has arrived from Japan. We bought a Gen 1 motor with its inverter and PDM. We brought our forky, aka jalopy, back from the block. We just knew it would come in handy. The engine is out. The tray is off. Exhaust, fuel tank, all removed. The coupler couples the Leaf motor to the flywheel. A lot of time went into the design of the coupler. Measured and remeasured. A 3D printed model was also printed to help us and the guys who eventually did the machining. A common question: do you keep the clutch? It is certainly much easier to do without the clutch. We decided that we wanted to keep it. So, a thrust bearing is then required to support non-axial forces acting upon the Leaf motor. Milling the adapter plate. The Big Hass machine made easy work of it. More than plenty of time went into the design. Again, a 3D model was printed. Assembly of the adapter plate, coupler, and thrust bearing, to the Leaf motor. To the keen observer, you'll notice the flywheel has been reduced, and no ring gear. It was much easier to assemble the motor using the engine stand. We even took the motor for a quick spin.
C50, that's torque. RPM. Oh. So I'm at 15 torque now. That's it. Okay, I would say this is probably good, so we can try to push it in. Francisco, as soon as it feels approved, you want to rev it up a bit more, or are you happy?
You can rev it up as far as you...
well, there's no oil in it, so is that a problem?
in the gearbox?
No.
Yeah.
Did you just drain the oil, or did you wash it?
No, just drain the oil.
Yeah, it should be okay.
You want to spin up a bit more, or are you happy?
A little bit more.
So about 15 was holding the speed.
Yeah, a little wobble up there, aren't we? A little four-wheel drive.
If you just drain the oil, you should be able to run it without any trouble.
Fitting the motor and gearbox assembly to the car was not as easy as we thought. I think it would have been much better if we had a tall gantry and fed the unit from on top. I was lucky as I designed most of the electronics before the terrible component shortage. We differed to the majority and decided to use lithium titanate chemistry. Although energy density is low, these cells feature well in every other category. High cycle count, 10 times that of other chemistries. No effective fully discharged. Wide operating temperature, -20 C to +50 C. Much higher C rate, both discharge and charging. Typically 10 C. Very safe. Overcharging, short-circuiting, does not cause combustion. The rear battery box fits under the tray. This box will store approximately 2/3 of the total cells. I hope you've enjoyed the video so far. I plan to cover aspects of the project in more depth in individual videos. If you wish to follow this project, you should subscribe, like, click the bell, and check out my upcoming Aptera videos. Thank you.